A logarithm consists of a base, some input, and it's equal to some number. This is called a logarithmic function, and it's directly related to an exponential function. So essentially, the entire log is the exponent, and can be represented like this. If we wanted to explore a little bit about logarithms, based off of this definition, we can first see what is log base b of that same base. So what is log base b of b? Basically, what happens if the base and the input are the same? Let's see what we get. So we don't know the answer yet, so we can just call this z. And of course, following the definition, the entire log is always equal to the exponent. So just following this rule, we can set up this situation here. So log base b of b equals z is the same thing as b to the z equals b. So remember, whatever's inside the log, that's what the whole exponential is going to equal. So that's why it equals b, because inside the log is b. Well, what does this mean? Well, b, another way to write b is b to the first power. But this would mean that z equals 1. So therefore, z is equal to 1. So therefore, log b of b is equal to 1. So we've discovered this fact. Log base b of the same input. So whenever the input and the base are the same, the answer is 1. Let's see what else we can find out. What if we had log base b to the n power? We don't know yet what that is going to equal, so let's just say it equals a. And then following the same rule from the definition, we know that the entire log is equal to a, so that a is the exponent. And whatever is inside the log function, that's what the exponential equals. So the base to the exponent equals whatever is inside. So b to the a is equal to b to the n, because b to the n is what's inside the logarithm. So from here, the only way for this to be true, that would mean that a must equal n. So a must equal n. That means that log base b of b to the n is just equal to n. So basically, it seems like the log b and this b kind of cancel, and you just get left off with the exponent. We found out that log base b of b to the n is equal to n, but what if this b is different from the base? What if this number here is different from this base? Like for example here, log base b of x to the n is equal to c. Well, using the definition, we know that the entire log function is equal to some exponent. So we can say that the base to this exponent is equal to whatever is inside the log. So in this case, b to the c is equal to x to the n. And now we can try solving for x. So to do so, we must take the nth root of both sides. So taking the nth root, n divided by n is 1, so x to the 1 power, or just x. And here we get b to the c divided by n, like this. And now we can use this property again. So if we do so, we know that the entire log function is equal to an exponent. So we can say that log to base b of x is equal to this exponent. So log base b of x is equal to c over n. And now we can multiply both sides by n. Doing so, we get that n log base b of x is equal to c. But we also know that c is equal to log base b of x to the n. Therefore, we can say that log base b of x to the n is equal to n times log base b of x. Another way to show this fact is like this. Going back to the same definition, we want to figure out what is log base b of x to the n. Well, we don't know what it is, so we can just call it c like we did over here. But by doing this, we know what x is because the definition, x is equal to b to the y. So that would mean that x to the n is the same thing as b to the y to the n, because b to the y is equal to x. So these two must be equal. Simplifying this, we can just call it b to the ny. And from here, we can take the logarithm of both sides of this equation with respect to b and get that log base b of x to the n is equal to log base b of b to the ny. Well, what is log base b of b to some power? Well, over here we figured out that log base b of b to some power was just the same power. So that means that log base b of b to the ny is just equal to ny. But what is y? We said over here that log base b of x is equal to y. So therefore, we can say that log base b of x to the n is equal to n times log base b of x. So whenever we have an exponent here, we can just bring it to the front like this.